All right, so the 3.1 worksheet. So we're going to work through a couple of the problems to give you all an idea of how to work out these problems. So let's start with number one. So number one, my directions tell me to make a conjecture about the next term in each sequence and then find that next term. Okay, so number one, we have got a sequence of 12, 21, 30, and 39. So we need to see what is the same thing that's happening. How am I getting these numbers? Okay, so from 12 to 21, I know that I get there by adding 9. From 21 to 30, I know that I get there by adding 9. From 30 to 39, I know that I get there by adding 9. So it seems like my pattern is with each new number, the way to get it is I add 9. Okay, so two parts here. First, make a conjecture about the next term. So my conjecture here is going to be I am adding 9 each time. And then after making my conjecture, I need to determine what would my next term be. So I would just take 39 and add 9 to it, and I'm going to get 48 for my next term. All right, now number 10. So number 10, I'm asked to determine what will be the next item in this sequence. Okay, so as you can see, I've got this first shape, then here, and then here. So it seems like with each shape, I'm keeping the original, and then I'm adding one more, but I'm flipping the triangle upside down. So here I had one triangle. Here I've got two triangles, one flipped right side up, the other upside down. Here I've got right side up, upside down, right side up. So the next one should be right side up, upside down, right side up, upside down. For number 12, I need to make a conjecture based off the statement that I'm given and then draw a figure to illustrate my conjecture. So with each of these, you are given one statement and then asked to basically imply another statement from your original statement and then draw a picture to represent your conjecture. So number 12, I'm told the statement M is the midpoint of segment AB. So I got to think, what does a midpoint do? What is a midpoint? And if I remember from Unit 1, a midpoint is just literally the point that is directly in the middle of, in this case, a segment AB. So if I was to draw out a picture of what this thing could look like, I have my segment right here, AB, listed by its endpoints, and then point M straight in the middle. And not only that, because I know that M is the midpoint of segment AB, then I know that M splits AB into two equal pieces. Okay, and these equal pieces will be segment AM and segment MB. So the conjecture that I could make based off the statement that M is the midpoint of segment AB is that I've got two smaller segments, AM and MB, that are congruent to one another. And I've also got my picture here to verify that statement. All right, for number 16, I am asked to make a conjecture. Excuse me, I'm not asked to make a conjecture. I'm asked to determine if the conjecture that I'm given is true. Okay, so I'm given this statement. So this is the rule that I have to follow. All sides of a polygon are 5 feet long. So then a conjecture that's been presented to me is that, well, the perimeter of the polygon must be 20 feet. So where my counterexample is going to come in is if I can provide a counterexample that stays within the bounds of the given, okay, so I don't disobey the given, but I can disprove my conjecture, then I've made a successful counterexample and I've proved that conjecture to be false. So I need to not break the rule of all sides of my polygon must be 5 feet long. Well, this conjecture leads me to believe this would be a four-sided shape because all sides of the polygon must be 5 feet long, so 5 times 4 give me 20. But it doesn't say that it has to be a four-sided shape. So if I drew a triangle, for example, right here, and I made each side have a length of 5 feet, then I've got 5 feet, 5 feet, 5 feet, add those together, and now my perimeter is 15 feet, and I stayed within the bounds of my given. I did not break my given rule. I have a polygon where all the sides are 5 feet long, but my perimeter was not 20 feet, it was 15 feet. So I've proven this conjecture false by using this counterexample.